Good morning, sir. This is Cadet Balicastro, and I'm about now to tackle what is Coriolis Effect and explain what is Coriolis Effect and illustrate what it is. First, what is Coriolis Effect? Coriolis Effect is an effect whereby a mass moving in a rotating system experiences a force or a Coriolis force acting perpendicular to the direction, motion, and to the axis of rotation on the Earth, and the effect tends to deflect moving objects to the right in the northern hemisphere and to the left in the southern hemisphere. And it is important that the formation of cycloning weather system. So right now I'm about to illustrate what is Coriolis effect. Have you ever watched the news during a tropical cyclone in your television? You've probably noticed that the big storms spin over time as they travel in the northern hemisphere. They spin counterclockwise. But if you're watching a storm in the southern hemisphere, it's spinning clockwise. Why do storms spin in different directions depending on their location? And why do they spin in the first place? And here's the thing. A storm rotation is due to something called Coriolis Effect, which is a phenomenon that causes fluids like water and air to curve as they travel across or above the Earth's surface. Here is the basic idea that Earth is constantly spinning here, constantly spinning around its axis from west to east. But because Earth is a sphere and wider, the middle points here in equator around an equator are actually spinning faster around the axis points than here, than the north pole. Yan, as you can see. So imagine if you're standing in the Texas here. Standing here in the Texas and had a magic paper plane that could travel 100 miles, and if you threw your paper plane you're directly northward, you might think it would land straight north. You might think it lands straight north, and maybe somewhere in Nebraska, here in the Texas, as I given an example. But Texas is actually spinning around Earth's axis faster than Nebraska. Is because it's closer to the equator. That means the paper plane is spinning faster, as well as when you throw it in spinning momentum is conserved. So if you threw your paper plane in straight line toward the north up, it would land somewhere here. Again, if you threw again your paper plane, it would be taking curved path just like this. You think it says that the the Earth is spinning. So if you threw your paper plane upward, it might probably go here. It will curve just like that. Curve at to the right and opposite. It would have happened in the southern hemisphere. Maybe in Delaware. So from your point of view, in Texas, the plane would have been taken curve path to the right opposite. Curve path to the right opposite would happen in the southern hemisphere, on an object traveling from the equator to the south would get deflected to the left. So what does this mean have to do with the hurricane spinning? Well, at the center of every hurricane is an area of very low pressure as a result of a surround by high pressure air surrounding the center of an eye, just like this. The area of responsibility, as you can see in your television, yeah, and this is the high pressure area surrounds the eye. Yan. And from constantly rushing toward the low pressure void, the center, in the but the because of Coriolis effect, the air rushing toward the center deflected from course. As you can see before it formed, the high pressure surround the low pressure area, and then but because of the Coriolis effect, it it deflected of course in the northern hemisphere, that volumes of air on all sides of an eye keep getting tugged slightly, just like this. It tug slightly to the right, and air keeps trying to make it easy way to the middle and keeps getting deflected, causing the entire system to spin in counter-clockwise direction to the southern hemisphere, and where the Coriolis effect pulls air and left opposite happen storm spin around the eye in clockwise manner. Thank you, sir.